All right, welcome to this tutorial on using the Resonant scanners. So at the start, you should have enabled Resonant scanner. It also doesn't really hurt to enable the adaptive focus control, or AFC, when you're starting LASX. 2 minutes after, you'll be greeted with a screen that looks roughly like this. If you prefer to set up your dye assistant, or if you prefer to use dye assistant to set up your channels, go ahead. You can edit these a little bit. So for me, example, I'd rather shift this excitation over a bit more. All right, let's try 545. I'm at least 50, or sorry, I'm 5 nanometers away from the laser, so we're good. Then we don't really need to be collecting anything out here because it's really unlikely that any emitted photons are going to be out in this range anyway. So I'm going to hit apply. Oh, I forgot to turn on the laser. I guess you could have gone here and switched it on as well. Okay, so it starts me off on high D2 in standard mode. So I'm going to hit live. You can see right away that we've got a noisy image. I'm going to check a couple things. I'll go to configuration, and I know I'm going to want photon counting. So it's grayed out right now. In order to enable it, I need to uncheck maximum integration time. I'm going to make sure this is on direct. So we're going to go back to acquire. Now I can switch from standard to counting. I guess before I do that, I'll go live. And you can see right away that these things are... this is not a useful image. There's 1, 2, 3, 4, 5 different pixels in here. It's either 0 or it's whatever this value is, or it's 160, right? So I'm going to go live, and I'm going to turn down the gain value here. And okay. At this point, at 10%, this is as low as it can go. But it's still 1, 2, 3, 4, 5, or 6 different information units. It's not great. I'm going to try focusing to see if that's the problem. All right. This helps a little bit. And then I'm going to position this guy a little bit more so that I can see all of this cool stuff. Great. So, I'm going to end up wanting to use line averaging or line accumulation. So I'm going to make the switch now to photon counting mode. If we go live again. Great. You can see there's no more spaces in between all of my pixel values, so I'm not artificially losing dynamic range. Let's say I want a larger field of view, right? So I could go to 1000 by 1000. So we were at 512 by 512 with an image size of 65 by 65 microns. If I go to 1K by 1K, image size hasn't changed because my zoom hasn't changed. So I'm going to bring it back a little bit to 1.25. If I go live now, we're a little zoomed in, as you can see up there. I'm going to readjust this a little bit more. Cool. And just making sure this is kind of the best focal plane we can be on. Something like this. And I'm going to turn off this auto lookup table. So I'm suspecting that we're going to need more signal, so I could increase the laser power here. I could also boost my signal to noise by introducing line averaging, or my favorite in this case is going to be doing frame accumulation or line accumulation. So why am I saying that? If I increase the laser power to, let's say, 2, I should get twice the photons, roughly. But these are neurons. They probably don't like high laser power, right? So I'm going to turn that down a little bit more to 1.5. You can take advantage of averaging to have it so that it's going to scan it multiple times, in this case 32 times on a line, before it averages all of that together. If you hit live, you get this kind of ugly looking image where these are 0 or 1. So we're going to set that to 1 again, and then we'll do this with frame averaging. So I'm going to hit capture image. It is not super great, right? We can be more confident that this is 2, this is 1, and that these are 0. Alternatively, we can do frame accumulation. So I'm going to capture image again. You're going to see it build up, right? So let's do that again. This was our first thing where we did averaging. This is after scanning it multiple times again, but letting it accumulate. So if your samples are moving really, really fast, you'll want to do line accumulation. Otherwise, there's going to be a big gap between what happens through time. But with line accumulation, because it's doing it up here and then moving down, adding it up again and moving down, it's going to reduce the amount of motion artifacts you would have to deal with. So with frame accumulation, though, it scans the entire image once and scans it again in its entirety. But this is really helpful because for noisy acquisitions, like this is one image with these resonant scanners, right? But if we even go up to 4, I'm sorry, I have to hit capture. It slowly builds it up. And then you get to decide, hey, maybe I need a little bit more signal because I have some really weak stuff. So you can say, let's go 8 times. Right, so this is a pretty reasonable image. Let's compare that now with an 8x frame averaging. There is a big difference in the quality between this averaging and this accumulation. So for the hybrid detectors, if you're lucky enough to just have an experiment where all you're doing is using hybrid detectors, this frame accumulation or line accumulation is fantastic. I guess finally, if none of these options are working well for you, maybe you know you want a little bit more detail, like I guess this 91 nanometer is not good enough for you. You can click on this button to tweak the scan format to whatever you would like, but then it'll set limitations on zoom factor and whatnot. So same image size, but now each pixel is a little bit smaller. Oops. And let's go back to 8. It's a pretty reasonable looking image. The other thing you could do, if you want to image even faster, turn on bidirectional scanning. And there you go. I think for this particular scenario, I'm going to try and maybe go back to 1K by 1K. Sure. I'm gonna leave this on 2 as I try and no. Do line accumulation 2 or 4 as I refocus one more time. So above, then I think this might be a little tilted, but let's say we're happy here. Okay. I think for the purposes of tracking, the 91 nanometer pixel size is good enough. If you wanted to change it, you could click on that plus and then tweak it that way. But we'll leave it at 1K by 1K for now. We've turned on bidirectional X, and we've optimized this phase X so that I don't see anything, so things aren't out of phase. To show you what that looks like, if this phase X is wrong, you'll see a doubling of your image, or if it's kind of close but not quite perfect, you'll see jagged lines. So we're going to leave that on 2. Yeah. It's going to... Yeah, 2. 2 looks good. All right. So, setting up your time lapse now. You can set your Z's just like normal. Go live, move the focus to some position, hit begin, move to the other end, hit end. But here I'm just going to do a 2D time lapse. So if you wanted maybe 500 time points, you could set that here. I'm just going to do something like maybe imaging every 5 seconds. But I want to image for maybe 2 minutes. So it does the math for you, right? Given how long between time points up here, and either the duration or the stacks, it can do the math for you. So 25 time points, including the first one, for 2 minutes. Or if you say you're bad at math, but you know you want 40 time points every 5 seconds, it tells you how long that'll be up here. So duration, number of time points, and then the interval. I'm going to switch this now to maybe 30 seconds. And let's see how many that gets us. So that's 364? Sure. Let's shorten this a little bit. Let's see what they can do in 20 seconds. All right. Sure, close enough. So I'm gonna switch off of line accumulation. I'm gonna do frame accumulation because this is kind of, these structures don't move that fast, and it's gonna kind of look really pretty as we watch it build up the signal. You can imagine though, if you had some structure that had more dynamic range, maybe you had some weaker filaments that you need to be pulled out a little bit more, you can kind of just keep increasing the number of accumulations, right? So this is a very nice and easy way of increasing your signal to noise without increasing your laser power or slowing your scan speed down. So the limitation, of course, is the max format size. So like it's less useful for fixed imaging if you need a big field of view. If we play this, all right, looks pretty nice. No appreciable signs of phototoxicity from this imaging session, at least. If you want to see what happens as we go maybe up to 16, let's hit capture. So that's probably going to mean that this saturates it out, or it's not going to saturate. It'll look blown out because of the lookup table setting. But if I drag this over here, I think this will be reasonable after we accumulate 8 times. 16 times. Whoops, hold on. We don't want time, so I'm just going to hit capture image. Great. So not too far off with my guess. Maybe... Let's see what happens if we bump up the laser power to 4. All right. Get even more signal. Now you can kind of make out the branches of these neurons. But the cell probably won't enjoy having 4% laser power on it. Let's see if we're saturating this dye by increasing this a little bit more. So from 4 to 8%. If we're not saturating, it should still be a linear increase. So we're at 42 right now. I'm gonna maybe say out here. Let's see if it reaches here. Okay. Definitely some... there's no need to go up to 8%. Probably like 7% might be sufficient. But you can definitely see a lot more of the neuron now. Let's try 20%. Let's just really blast this guy. Alright, it doesn't look like a pretty image, but that's a lookup table thing. You can either go here or tweak it using one of these things. Let's see. Yeah, so there we go. Even turn on some gating if we want. Maybe just a little bit. Alright, so that's kind of it. That was using the resonant scanners, setting the bidirectional X, and making sure that the phase was optimal. Showing you that frame accumulation and line accumulation can be used in order to really boost the amount of signal you're acquiring. Alright, I'm guessing we're kind of saturating it. Yeah, let's hit stop. Alright, let's go back to the more reasonable 1.5%. I'm going to move to a spot where I haven't super bleached it. Sure, how about here? So initially, it's 1 on everything. Looks really noisy. You can do both line accumulation and frame accumulation if you want. And that kind of lets you build up a lot of signal. So we're gonna hit capture image. Because we have the histogram up, we can see exactly where our values lie. And so this is a pretty good looking image. If there wasn't any motion during the time to acquire this image, then we're good. So that's it. That's That's how you get around the whole, oh, there's only 16 for frame accumulation or up to 16 for line accumulation. You can use both. What you can't do is kind of combine the two things, so you can't go line averaging and also line accumulation. You gotta pick one. So if you're really interested, let's see what happens with 4x line averaging and 12 frame accumulations. Yeah, not great. Probably wouldn't suggest doing something like this. Unless you, I guess this could be helpful if you have, oh, let's see. Let's leave it like this. We'll go back to building signal. So see, the background does add, right? It's not, so there's some little autofluorescence on the substrate that you're picking up with the accumulate only, but with the line averaging and then doing frame accumulation, all of this is 0 out here. So be careful how you do things. I would probably suggest stick with either line averaging or accumulation, but probably don't do both. All right. That's pretty much it. Your task is to get an image without saturating. If you're, one final quick tip, if you're doing analysis and you do find that you're saturating because your sample's really bright or something like that, just change the bit depth from 8 to 12. And then you're going to go up to 4,000 something. So let's go 16, 16, and you can watch it kind of build up from here. So the amount of time it takes to acquire an image like this means that if your sample is live, you probably don't want to have it be waiting for that long. But maybe you've got very slow moving things. 17 seconds for this image though. It's a while. But still, here's a very pretty image using the Resonant scanners. All right, thanks for your attention.